some issues, so I'm just gonna share my screen. And I hope everything works. So Jitsi is doing some laggy issues today. Not sure what's that. I've never faced that before.
Yeah, and someone was suggesting another platform, right? Yeah, so it does have some issues if we like cross like 30 people, but I think we are good for now.
Oh, I didn't know about that. So what you're saying that if more than 30 people join, it lags.
Ayan, this is Anul here. Are you live streaming this?
Yes, we are live streaming, right? So I'll just post the YouTube link here.
Yeah, so those who just want to follow along can go to the live stream, and that reduces the load over here.
Yes, that's the idea, right?
Yeah.
Yeah, thanks for the suggestion.
Awesome, thanks, Anul.
Yeah.
Yep. So let's start, and I'm gonna share my screen. So someone just let me know if you can share my. You can see my screen. So can you see this?
Yes,
Yep.
we can see the screen. Also, Zion posted the YouTube link, so so everyone can join it there as well. So they have
Yeah. So as Lok and Anul suggested, if a lot of people join on Jitsi, it starts to lag. So if some of you can move to the YouTube stream, which Zion has posted the link, that would be really helpful. So anyway, so we are all logged in, but we are together and we will do better. So that's the idea behind Hardware Hackers Club and India Linux User
also,
Group Delhi Virtual
Zion
Meetup.
posted
So
the
far, we have
YouTube.
done 3 sessions. This is the 4th session, which is going to be on Kicad, whatever you like to say that. There's a calendar we are shared. So we have almost 3 weeks of events ready and more coming in. So we have completed almost 4 of them, I believe. There are more coming, and this is the schedule. There is also quizzes weekly and volunteer calls. If you would like to be a part of that, please feel welcome. Regarding ILUG-D and Hardware Hackers Club, both are open meetup groups, all volunteer driven. So if you want to be contributing at any way by proposing a talk or just want to stop by, please feel free. The platform we're using is Jitsi. For now, if we have any problem, we have no issues moving to some other platforms. For the quiz, we are using Kahoot. So if you want to take part in a quiz, the next one is coming on Friday, which you can use this application to download and be a part of it. And yes, the quiz now will also win a beautiful plant, which we're going to ship after the lockdown is over. We are live on YouTube, so that's the channel link for India Linux User Group Delhi. And you can see that if anyone has any problem showing their face, it's better to turn off your cameras, and now is the best time to do that. We are on Telegram, active groups for both Hardware Hackers Clubs and ILUG-D, and we're also on Twitter, where you can follow us and stay connected for more events. We're also on the Meetup page. That's the link where we announce all our events. There's also our mailing list, but I don't think I have any link for that right now. So if you're a company or organization and wants to sponsor these meetups, you will help us to have more such events, and we are happy to place your logo over here. So just reach us out if you want to be a part of that. Code of conduct we follow for all our virtual as well as real life events. So in short, just be nice to everyone. And if you want to read the entire COC, that's the link flashing on your screen. So quickly gonna tell you how to make the best out of these sessions. So Jitsi, when you join as a new user, it shows your name as a fellow Jitsier. If you go on settings and under profile, you can change your name. That really helps us to identify who is asking the questions or speaking. Please follow code of conduct and stay nice to everyone. Mute your microphones at all the time. If you want to speak anything, use the raise hand button on the Jitsi, and then you can speak by unmuting your microphone. You can put your question in the chat window with a Q in front. That way we can take the question after this session. Or if you want to say directly the questions, you can also do that at the end of the session without by unmuting your mic. If you want to propose a similar session, we are taking all the talks on open source, Linux, tools. You can do that by opening an issue on our GitHub talks repo. So yes, that was all about today. That was all about the meetup groups. Now, not about today. Hang tight. So I'm just gonna pull about today's session. So today's session is going to be getting started with Kicad or Kicad. The community has agreed to be okay with both of the pronunciation, so you can pronounce it as you like. So this is a beginner-friendly session where I'm going to be talking about how to use the Kicad for schematic capture and PCB designing. And we're gonna do this hands-on. I'm gonna make a very small basic board which you can do it yourself. And if you have already some experience designing PCB boards, maybe you want to switch to a free and open source tool, which is KiCad. This is also a session for you. So starting with a quick quote by Richard Stallman saying, "Open source is a development methodology and free software is a social movement." So at ILUG-D and Hardware Hackers Club, we are really promoters of open source technology and software, and uh, that is what we believe in: freedom of using things and sharing code and improving it, building a community around it. And KiCad is no different, and that is the reason for this entire talk. I'm going to give a small introduction about myself. So I work as an automotive embedded software engineer at Mentor Graphics, which is now a part of Siemens Digital Factory Group. Most of my work revolves around creating custom embedded Linux for automotive applications like self-driving cars, active noise cancellation inside car cockpit, cluster domain consolidations, multimedia kind of applications, and all kind of things. Other than this, for hobby, I build and fly FPV racing drones. So if you do not know about FPV drones, these are the drones which you fly with the headset, getting a live feed, flying at a very fast speed, mainly for freestyle and racing. I make videos about that on my YouTube channel as well. Other than that, I promote open source hardware and software by giving such talks at different events, and by making content at on my blog and YouTube channel. So these are some of the links which you can use to see my work. So I blog, I have a YouTube channel, and I put most of my projects on GitHub. I'm just gonna wait 5 seconds if anyone wants to take a screenshot. Awesome. A small disclaimer before I start today's session. So first of all, I'm not a KiCad expert or an EDA expert. So please bear with me if I make some mistakes. I'm not an expert. I just know enough to be dangerous. I've been using this tool for quite some time now, and I've designed a lot of different boards over the years, but I'm not an expert. And maybe some of the people who have joined the call has been using KiCad for more than me, and definitely they know more than me. But this is a heavily requested session at ILUG-D. So a lot of people have requested a session on KiCad. So yes, I thought of doing a getting started session for 101. But there are some really amazing people in our community, in KiCad community, who are doing amazing sessions. Anul is in the call, who has been doing weekly streamings of KiCad sessions. Those are basically some advanced sessions and hacks and tricks. So I highly recommend to join that as well. I'm going to post some links after this talk, but this is a getting started session. I'm not an expert, but I just know enough to be dangerous. So yes, again, a beginner friendly session. So if you have no prior experience designing PCB boards at all, you're welcome to join this session. And I'm pretty sure that this will help you to make your own circuit boards or circuit design. Everything cannot be covered in one session. This is a really massive tool, or I would say a collection of tools which has been built by community over decades. So everything cannot be covered in one session, but this will sure get you started. And on the bottom, you can see the links to the slide if you want to take a quick look after this session. So this session is okay. Hold on. Is there any problem seeing my screen? I'm getting some messages.
No, it's fine.
Okay, it's fine. Yeah. So
yeah. So your screen on YouTube is frozen for some reason.
Okay. So let me just do it again if that helps. Yeah. So I restarted screen share, and hopefully this will not be a problem now.
Zion, can you check?
So this one is gonna be a bit longer session than we usually do. So usually at ILUG-D we do about 45 minutes to 1 hour session, but since we are gonna do hands-on, it's could be I'm guessing around 1.5 to 2 hour session. So that is there. Before going ahead, I just like to say if you have any questions, I would like to be interrupted. Just please pause me whatever I'm doing. I'm happy to answer that. If you have any query, just unmute your mic, just ask me directly. That's how I prefer. If you want to wait for session to end to get your answer, then you are most welcome to put your query in the chat session. But the the answer to this question can be different for everyone. Why I learned PCB designing? Because I started a company back in my university days, and we were planning a product, and there was really hard to find a PCB designer around. So I decided to get my hands dirty and do it myself. Back then, I started with using a software called Eagle. So that is how I started. But the stuffs which we wanted to do really require either the pro license or hacking around a lot. Then entered open source. So Kicad being open source has so much flexibility, has an amazing community around it, has amazing forums where people are so active and are available to answer anytime. So I switched to the Kicad. I've also used Altium before, but I think that is for really pro level stuff if you are doing something for really good production. That being said, that is not true that you cannot use Kicad for production level boards. There are a lot of different projects which I'm going to show you in a bit, which have been made around using Kicad, and it works great. It is one of the amazing open source EDA EDA software that's available right now. So even if you are a software developers, which I'm sure pretty much of the audience are from a software background here, even then, if you have any hobby project which you want to make as a reality, then maybe you have to consider having a PCB board around it, and that is one of the reason you could consider learning PCB designing. Talking about the KiCad, KiCad is an open source software suite for electronic design automation. It handles schematic capture, PCB layout with Gerber output. So Gerber is basically the industry standards for producing the PCB boards, which I'm going to talk about when we will be doing some demos. So it runs on Windows, Linux, and Mac OS. So yes, that is a cross-platform application, and it is licensed under GNU GPL v3. I'm not sure if it started as V2, but now it's V3. So that's about Kicad. Some quick facts: its first launch in 1992. It was around the same time this ILUG-D group started. So it's pretty old and has seen a lot of development over the years. It is in a very active development stage. So currently we are, I believe we are having Kicad release version 5. For some reason, for my laziness, I'm still stuck with version 4 because I've not been upgraded. But yes, the recent version is 5. And a very active community. So there is no issue finding answer to whatever questions you have. So I think I just, yeah. So CERN Laboratories Geneva is one of the active contributors to Kicad. They started contributing to Kicad project starting 2011, and they have contributed some really amazing feature to the project, such as like push and shove router. So that is when you are routing your board components. So yes, other than CERN, there are a lot of different other organizations like DGK is one, and all of them are contributing to Kicad and making it a better software and community in whole. It is also now a part of Linux Foundation project starting 2019. So another good thing. Kicad also hosts an annual conference. The first conference, I think it was held in Chicago. I'm not really sure in 2019. But the next conference this year was going to be held at CERN, Switzerland, Geneva, but it is now virtual, keeping in view everyone's safety with respect to the COVID-19 situation. But that is not to be disappointed with because next year, during September, it is hopefully going to be at CERN, and maybe some people from here could be consider being a part of that. Talking about the capabilities, it is the biggest capability of Kicad is being open source, which is the completely open source and free to use software. So there is no restrictions. You do not have to pay anything. You can modify your source code. You can make plugins for it. No one is stopping you. Talking about on the EDA level, it can do up to 16 layers of board. 16 layers of board you can make with Kicad, but again, if you are not designing some really high speed motherboards for server level microprocessors, then you are okay with being with few layers like 2 to 4 at max. So, but again, the feature is there and no one is stopping you to do that. So yes. It supports scripting. So I believe when I was using Eagle, ULP scripts was there, which helps a lot. In Kicad, it supports scripting as well. A lot of the things are marked in XML, which allows using Altium or someone who is using Eagle. There are some plugins which you can use to convert your project from Altium to Kicad, from Eagle to Kicad. And other than just converting from one tool to another, there are also some other amazing plugins. So one of the plugins which I use is KeyCost, which takes the bill of material from your Kicad project and it parses all the vendors which provides chip, for example, Element 14, DigiKey, Mouser, and it fetches all the links to your component matching the footprint. So it's really handy. Other tool is FreeCAD. There are plugins which allows you to easily seamlessly take your project KeyCAD to FreeCAD. So it's basically for designing 3D. You can design 3D enclosure, or you can design 3D views of your boards. And I'm going to show you how you can utilize that feature in some later streams. But it's a lot of good plugins are available. It also for PCB art projects. Over some years, we have seen that a lot of people has been doing art using PCB, which is not initially the intent of PCB, but by exploiting some of the PCB manufacturing processes like screen printing and solder mask layer, people have come up with some unique designs of PCB, especially in conference batches, or I should say hashtag the batch life. Or if you have seen even the PCBs having no circuits, but because they are so cheaply manufacturable these days because of a lot of board houses in China, you can use that to have some basic good artwork. So these are some important links. I recommend taking a screenshot of this one. So this is the Kicad website where you can download for your distribution. Whether it's Linux, OS 10, or Windows, there's a quick start guide, documentation, tutorials. I highly recommend, if you're using Kicad, to join the Kicad forum, which is a great place to ask questions, and it's really active. The source code is hosted on GitLab if you want to contribute. And the best part of contributing to an EDA project is there are a lot of scopes to contribute. For example, every day hundreds of components are being released in the market by semiconductor companies, right? And as a PCB design software, this is not possible to have all the components footprints and schematic designs available. So if you are using a component and you have made a footprint, then you can consider upstreaming it to Kicad libraries. So that is another good thing. Other people can use that. And it's really easy sharing your libraries and components. And again, since it is open source, please consider being a part of it as a contributor. So let's start with some fun. So I have a couple of slides more before we move to the Kicad. I'm just gonna take a 5 minutes break so everyone can drink water and just be ready for hands-on now. So I'll just take let's take 2 minutes break and we'll start again in 2 minutes. By the time I'll check everything is working fine. All right, so just checked everything is working good, and let's start with the PCB development phase. So these are the steps which one needs to take when designing their own PCB. So I'm gonna quickly show you one by one, and I'm just gonna quickly translate how everything moves to the EDA software, whether it is Kicad or any other software. So first of all, the first thing you need to do is start a new project where you give a project name and the location of where you want to store the project. Then you need to design a circuit, and this step is usually also called a schematic capture. So you get a canvas to work in where you put all your components and you put all the wires going from one component to another. So this is basically called a circuit design. So if you are an advanced electrical or electronics guy, you may be able to design your own circuits. But if you're not, you can exploit the you can make use of the open hardware thing, and you can get the circuits online what you are trying to do, and that is a really neat thing. So once you start the project, you design the circuit. The next thing you do is check for electrical. So it's also called ERC, or electrical run check. What electrical run check, it's like a compiler but for your circuit. So when you write a code in compiled language and then you run the compiler, it tells you if you have forget a semicolon, if there is any compilation error there. Similarly, an ERC checker, what it does, it tells you if you have missed connected components, if there is some possibility of short circuit, and if there is any miss wire or some other things, if you have forget to put the value or the name of the component, ERC will tell you, and that is a really handy feature in all the EDA softwares. After running an ERC check, you create a netlist. So basically, what is a netlist? Is netlist have data of which component pin is connected to which other component. So, for example, one component is having 10 pin, other components having 12 pin. Three of them are connected. So netlist will have all this data of which pin is connected to which pin. That is the use of netlist. Other than after creating the netlist, you have to create you need to associate the footprints. And what I mean by associating the footprint is, for example, an LED comes in a different footprint. You can have a through hole LED, you can have an SMD LED. In SMD LED, you can have a 0805 package or 0603 package. If it doesn't make sense to you, just consider that LED comes in all shapes and sizes. But the symbol for LED is same, because when we draw a circuit diagram, there is no change in that. The symbol is same, but the footprint can be different. And depending on what kind of LED you want to use, you have a flexibility to associate that footprint to your netlist. So once you do that, the next step is to make a PCB board, which is also where you place all the components in your board. And so we created the netlist. So when we draw the PCB, we know where each components are connected to which, and you will see some flying wires, which are also called rat nest, which allows you to see which components are connected to which component and makes it's easy for you to place. After, oops, I just clicked back. Never mind. So after making the PCB board, you need to route the components. And what is the meaning of routing components is connecting one component to other component, which you have which information is available in the netlist. So you have to import your netlist, you have to import your footprints, and then you need to start connecting it. So you can do it manually. I prefer doing it manually, but there are also some automatic routers which have some algorithms of finding the shortest path and shortest cost and routing the components for you. Most of the times self-routing can help you, but there are certain times when you're designing complex board when self-routing fails, given how you place the components, then you can do self-routing plus manual routing both. So that is another great feature. As I mentioned, CERN has also contributed a push and shove router. So that is also a very efficient router which allows you to manual route, but if there are other tracks in your way, it will automatically push them above or beyond depending on how you have layout your board. So again, you need to compile the circuit. Now you have to compile your board, and what I mean by compiling the board is doing a design rule check or DRC check. So in the design rule check, it do not tell you if everything is connected, because that has already been done in ERC. But in DRC, you need to have some set of DRC already available, and where to get that? You get them from your PCB house. So every PCB house has some limitation, like what is the minimum length of a track they can do, what is the minimum hole size they can do, what is the size of a VR they can do. So you can see the information of all this in your fabrication house's website, and you can download that. You can put it on your Kicad, and accordingly, if you violate any of the rules set up by your fabrication house, the DRC will generate an error. So you can fix that error, and then you can export your board for fabrication. This step is really important because if you have any error in DRC, there is a high probability that your fabrication board will fail in early evaluation, or your board, even if it's fabricated, it may have some bugs and it's not functionable. So again, a really great step. Again, I pushed the wrong button. Okay, so one step ahead, you need to generate the Gerber file. So a lot of the PCB houses now accept directly the Kicad or EagleCAD or other software project file, but it is always a great idea to generate Gerber files and give it to them. So once you generate the Gerber file, it is a industry standard. Gerber files are sent zipped and sent to PCB houses. You can upload them on their website, and they will do the PCB fabrication for you. So that is the entire process of PCB fabrication, and these all the things which we going to do when you are deciding to go for a manufacturing. Starting, generally, we order some limited quantity of PCB boards and check everything is working. If we are happy with it, we can do for a mass production, and depending what is your product requirement. So this is a generic kind of flow diagram which every EDA software wants you to do. But now if we talk about the Kicad, this is how it looks like. So in Kicad for designing circuit, so I initially talked that Kicad is not one software, but it is a collection of different software being packaged together to take advantage of one another. So in Kicad for designing circuit, the software is called eSchema. For ERC, there is electric run check, there is ERC. For Netlist, there is Net. To associate the footprints, there is CVPCB. For making a board, there is Pcbnew. Routing component you can do manually or using a router. For design tool check, there is DRC. For generating the Gerber, there is a plot, and then you can fabricate. So your mileage may vary of different softwares and doing what things. So if you're working on a very big team, there is a chances that you only have to design circuit, and some other guy is working on routing, or some other guy is doing something related to DRC and all. But if you're working in-house for some small project, you all have to do it yourself, and your mileage may vary depending on what you want to do. But there are some other add-ons on top of this, which is also essential. For example, oftentimes you want to use a new component in the market, and you cannot find the component symbol available online or in the inbuilt libraries. So Kicad comes with a bunch of inbuilt libraries which you can use. But if it's not available, Kicad provides you a symbol editor for that. So you can make your own symbols. Similarly, when you make a symbol, you also need to have a footprint. Symbol is for circuit, footprint is for PCB. And if you want to use a new component whose footprint you cannot find, Kicad has a footprint editor which allows you to make your own footprints. So again, some added top-ons. There is a 3D viewer built in Kicad which allows you to view your board in 3D mode, and that is a really, really, really helpful feature. And I cannot express more that how good it is to view your board from all the angles before fabricating it, and you know which components is placed where, and again, a really amazing feature. Eagle also has a similar kind of thing where they have plugins for Autodesk Fusion 360, and that also allows you to build PCB enclosures for 3D printing. But because Kicad is open source and have source code available, people can write scripts, and people can use the extensions for Kicad. So we also have FreeCAD, which allows you to do similar things. Then we also can generate bill of material, which is basically a spreadsheet of what all components you use, what are their quantity, and where to buy it from. There is also SPICE simulation. So if you want to simulate your circuit that it is exactly working how you want it to be, then you can use external SPICE simulators. How SPICE simulators work, they import the netlist which you have created, and based on this netlist, they can tell if the circuit is really working as you want or not. So again, a really great feature. Other feature which has been added to Kicad is bitmap to not PCB, so it's actually called bitmap to component converter. So you can take some bitmaps which you can design in your softwares like Inkspace or Autodesk, Adobe Illustrator, and you can import them in your PCB. Really being used for PCB art, which I mentioned. So just wanted you to show some of the projects which are made with Kicad, and if you want to see more, you can visit the website mentioned above. So these are some of my board which I did this year. So most of them are two-layer board, and you can also see some single boards are there and some panelized boards are there. So Kicad also allows you to panelize your board. What I mean by panel, if you see the rightmost board on this photo, small PCBs are arranged in a panel, and that is a really good feature which saves a lot of cost and time for manufacturing. And you can get a panel made for almost a similar cost. Like 5 PCBs, you can get 20 PCBs for same cost because you panelize it, and Kicad allows you to do that as well. There is this drone Crazy Fly 1.0, which is made entirely on Kicad. It's an open source indoor drone project. Uh, Again, a very good single boot computer based on ARM64 with 2 GBs of RAM, 4 GBs of flash, made entirely on Kicad. So you can see it's a really powerful tool. Some of the people might recognize this as Great Scott Gadget Hack RF. So it is like the god of software-defined radios, and it's made using Kicad. An entire laptop based on ARM64 and x86 processor is made on Kicad. An open source scope for logic analyzer and pulse generator is made on Kicad. The first open source satellite has been made on Kicad, so you can see that it's really amazing to see how people are using free and open source tools, because there is no fees available. There is no limit of what you can do. And one of my favorite is this year batch of Open Hardware Summit. So Open Hardware Summit couldn't happen in person, but it's a virtual summit which happened, and this batch is entirely made on Kicad. And I think Anul is here, who has helped a lot with this batch, especially with the 3D renders a lot of the components. So thanks to him, and yes, again, a Kicad, amazing Kicad project. Also, I talked about the batch life, and I wanted to share some of the really good projects which has been made using Kicad. So as you can see, these are not the PCBs which are meant for doing some traditional thing, but these are actually the art. These are the PCBs using some art in the front and LEDs in the background and doing a lot of kind of things. So on the left, you can see some of the work by Mr. Twinkle Twinkie. He is one of the pioneer of batch life, DEF CON, and Hackaday guy, amazing guy, and makes a lot of different batch life projects. On the right hand side, you can see even I designed one of the batch for ILUG-D and Hardware Hackers Club upcoming soldering workshop. So it's still stuck in customs, but soon we're gonna get that, and we'll have some fun with that. So yes, all these projects are made on Kicad. Okay, so before making a PCB, before designing a PCB, it's really important to understand what goes in making a PCB, and that really allows you being put together. So this is the basically two-layer board with the copper on two ends. There is a substrate, a solder mask, and a silkscreen. So let's quickly talk about what are the features of this layer before moving to the hands-on. So what is a substrate? A substrate is basically a substance which holds everything together. So the most common substrate we use for PCBs are FR4 or fiberglass fiber board. So this is a plasticky fiber board kind of thing, which is used to hold all the PCBs together. So this is the substrate. Second layer is the copper layer. So on the substrate, using some industrial process, a layer of copper is pasted on the. If there's a two-layer board, it's pasted on the both sides. If there's a one-layer board, it's pasted on the one side. And if there's a multi-layer board, there will be multiple copper layers between substrate layers on the PCB. So that is the copper layer. The next layer we have on top of the copper layer is solder mask. So what is the meaning of solder mask is it actually is a mask. So Everywhere you want to put a component, you can say exposed copper, but other than that, you can see a coating, generally a green coating called solder mask. Nowadays, you can have different colors like blue, red, white, even black and matte black. Some PCB houses also doing matte black like PCB way. So solder mask is basically help to place all the components in the right positions and also prevents any electrical shock because all the copper tracks are being masked, and the only the places where you need to put the pins of the components are exposed. So that is the feature of solder mask. Silkscreen layer is the next layer, and Silkscreen is mostly used for writing some information on top of a PCB. So you know where is resistor number one R1, where is resistor number two R2, and such that. So it is basically started as an information providing layer, but nowadays, as you see, PCB batches and batch life, Silkscreen is used widely for even other tasks. And Silkscreen is basically the process used for having silkscreen on a PCB is screen printing. So if you are aware about that, that is the same process being used for screen printing. So let's design some boards. So I've talked a lot about the PCB design process and anything. I'm take 5 minutes to have any questions. So if you have any questions, just unmute your mic. If you want to say anything, just unmute now and say it, and then we'll move to designing some PCBs. So do we have any questions? Okay, so any questions, anyone, before we start with the actual software? Can the moderator tells me if there is any questions on YouTube?
No.
All right then. So I'm just moved to other laptop. This is my work laptop running on Windows, which I use mostly for PCB design. And I'm just gonna share my screen from that laptop. Word of question: this laptop is on a dock. That means it don't have a battery. So if I disconnect somehow, just wait patiently for some time, and I'll just reconnect it. I hope that doesn't happen, but just in case.
Hey Anne, is there a question by Ashok in the chat? Can you read it?
Yeah, can you read that up to me? Or hi, I have a plan to develop HMI. How can I help me? HMI, do you mean human machine interface? If that is the thing, then in the terms of PCB designing, having an HMI, you can do it in a lot of different ways. One way is to have a display and a bunch of buttons, like push buttons or something. Other than that, one thing that is really common these days in terms of HMI is having some conductive pads. So a conductive pad is basically a bare copper which you can use with a microcontroller and detect when it is touch. It's capacitive touch. So using that, you can create some HMI. By HMI, I'm understanding as human machine interface of some sort. But correct me if I'm wrong. Yeah. So I believe that answers your question. Having some buttons and screen or a conductive pad. So these are the most common things which I have observed people doing HMI with. Okay, so again, I'm not an expert on this one, so if I make any mistake, just please excuse. And also, I'm gonna make some mistake intentionally to see how things go. So this is the Kicad. You can download it from Kicad website, and as I mentioned, this is a collection of different tools. So as you can see, there are a lot of different tools on this panel. On the above, there are some basics file explorer functions. So the first thing which we need to do is start with a new project. So I'll go to the file, new project, and I'll start with a new project. And I'm just gonna save it to wherever I want on my file explorer. So let's name it and say Kicad workshop. Okay. So by the way, I have enabled this trial extension where you can see my keystrokes. Thanks to Contextual Electronics for suggesting this one. So because I'm going to use a lot of shortcuts, because a lot of my workflow in Kicad involves a lot of shortcuts, and that is why I want you to see all the shortcuts I'm using this application. So there we go. In this folder, I'm gonna name my project as Kicad Meetup, and .pro is the extension for that. So once I save it, you can see it generates schematic and PCB automatically. So that is the feature of Kicad. So if you go back to my slides where I mentioned the entire PCB design process, so the first step was designing your own circuit board, designing your own circuit and the schematic. So circuit and schematic, you can go with the .sch or schematic. You can also open it using this. So eschema, as I mentioned, is the program which is used for circuit designing. So I'll start the eschema, and you can see this is the canvas here where you can design your circuit. So the idea is to design your circuit inside this canvas. You can also break this canvas into different part, which is a very good practice if you are doing a big project. But since we are doing a very basic project, we are going to stick with this canvas only. Over here, you see this is a sheet which generally people from background of manual CAD. So I don't know if that's even a word. So what I mean to say is architects, they use these kinds of boxes to define their project, the title, the sheet, the date, and everything. I'm gonna just ignore it sometimes. You have the feature to enable your grid mill unless it's needed to change the grid. Mill, if you do not aware, mill is a unit mostly used for PCB projects, and 1 mil is equal to 1,000 of an inch. So 1/1,000 of an inch is a 1 mil. So that is how we use PCB. The overall dimension which we can keep is in mm or inch. I like to keep it in mm. So over here you can see you have some small options. The most and is different options where you placing a component, placing okay, or is it okay? I think it's doable. So bus is something is like a collection of wires usually used for chips with memory, like a RAM or ROM, that kind of thing. You can you can place a junction, you can place a label, you can place a what you call local label, net label. You can also place some text over here and such kind of things. So once again, if you have any question, just unmute your mic and just ask me directly. So this is can make a quick basic circuit having one battery and two batteries. So that is the basic circuit we're going to do today. But again, as in layer, so you can do any circuit you want. So on the right, I'm just gonna go in this option called place a component. I'll click on that, and I'll click on my canvas to place a component. So as I so for some reason my keyboard shortcut is not working. So let me just quickly save it. Okay. As I clicked new dialog here, comes with key using an installer to ask you if you want to download these libraries. Recommend you do that because these are some libraries which are you're going to use on daily basis. Other than that, you can have contributed libraries for some other people who likes to put it on GitHub, or you can make your own libraries. As I mentioned, there are a lot of components whose footprint might not be available, whose symbol might not be available, and you have to make on your own, so that you can put here. But that is not something a good practice considered in Kicad community. In Kicad community, the good practice is to keep all the libraries bundled with specific for your project and keep when you start using it. First thing I'm going to do is place a battery because we need power. So you see there is a battery over here. I'm not really sure how Eagle is handling this these days, but when battery, 10-volt battery, 100-volt batteries, and all kind of symbols related to that battery. It is really one symbol for one generic component, and you can map it to other any footprint you want, which I'm going to talk in a bit. Uh, can someone confirm, is everything going good?
Seems good so far.
Okay, yeah.
It's all
So
right.
someone wrote on the comment that it's my connection worsening. So just put in the chat if something goes wrong. Okay, so I was saying that in Kicad, so this is a generic symbol which you can use with any value of battery. So I'm just gonna pick one battery here and place it right here. So battery. I'm just a component. So I just need to click again. So my selector is already there. I'll click again, and now I'll type. You can have to rotate the component. Okay, I think there's a little connection issue, but okay. If notice I'm still selecting this component, and if I press R, it is rotating. So that is a shortcut to rotate any component. So I'll just place one LED over here. Notice one more shortcut I'm going to use, and that shortcut is C. So if I hover my cursor on this component and I press C, this will copy the LED. So this is a small shortcut which you can use to copy the component over here. So these are the shortcuts. And if you want to see the entire list of shortcuts, what you can do is press this list where you can see all the list of shortcuts available in Kicad. So again, if you want to see anything, any shortcut, just press question mark. And I'm using all the built-in shortcuts for Kicad. So so far I've used R for rotate and C for copy. So I have two LEDs. I have one battery. I just need a series resistor. So I'm just gonna place a resistor over there. I click R, and you can see I have a resistor. So again, as I mentioned, in Eagle, you have a resistor for 100 ohm, 1.5K, 1 mega ohm, milli ohm, whatever. I'm not sure if they are still doing that way, but in Kicad, you have the flexibility of taking any component and renaming it as you want. Okay, so that is my overall circuit. So a resistor, two LEDs, and one battery. So now I need to connect all these together. How I'm gonna do that is over here. If you can see on the green color component called place wire, so you can either press that or you can go to the component and press W. So W is a shortcut for placing a wire. So what I've done, I have pressed W, and I'm just connecting the positive terminal of this battery to this resistor, and then I'm again pressing W to connect these together, and W to connect these two together. So this is a basic circuit for two LEDs in parallel with one series resistor and a battery. To place the ground, you can either do it this way. So one way is to do like this. So that's commit the circuit, but I'll show you one another way, which is I think a more recommended way. Both are right. There is nothing wrong in that, but you can see there's a symbol called place power port. You use that. You click one, and there is all the symbols connected to related to the power. So I'm just gonna find for GND, that is for just gonna here. I'll do again. I'll press W and connect it to this, and I'll copy another ground. I'll place it here. I'll click W and I'll connect them together. So this is another way, which is if you see some schematics online, this is another way of people making schematics, and I think this is a more common way of doing the things. So again, circuit complete. So that is the most basic circuit I have made for this small demo session. This is a circuit, but I'm just gonna tell you what are the different steps you need to do after making a circuit. So as you can see here, there is a BT question mark and LED D question mark, R question mark. So what are these? So these are called symbol annotations, and what I mean by that is you need to, if you have seen a PCB. So I'm just gonna show a PCB over here. So if you see a PCB that I designed few months back, you can see there are R1 written, R2 written. So what are these? So these helps me to identify which register is which, and you need to name all the registers here. So uh, either so one way is to you go there, hover your mouse on the component and press E. With E, you can change the fields over here where it's written D question mark. But an easier way to do is to go on this option called Annotate Schematic Component. So this is a built-in to Kicad option. So if you press on that, it will open this dialog box, and I'm gonna say use entire circuit, keep existing annotation, sort component by X, and annotate. So I'm gonna press OK. And now if you see closer, it will say R1, it will say D1, D2, GND, and BT1. So what it does, it's annotated the entire circuit for you, starting from the left-hand side, that is on the x-axis. So run. So it will tell us if there is any connection which we have missed or not. So over here, it's called perform electrical rules check. So I'm going to click on that. That is a sort of my compiler for EDA. So as we have compiler for C, C++, we have compiler for our PCB design circuits. And if we click that and I say run, so you see I got one error over here. So it says pin connected to some other pins, but not to drive it. So this is a weird error. It is trying to say is there is no driving circuit in this, and that is because the battery symbol is not mentioned that this is a power pin. So that is a bit more in what you can error which is not going to hurt you. So I'm just gonna ignore it for now. But I'm going to show you how this works if there is actually an error. So let's say I remove this wire. So I'm just gonna hover on this wire and click delete. Now there is no connection between the positive. If I'm just gonna run the ERC again and I run the ERC again, so you see there is another error which says pin not connected and no connect symbol found on this pin. Is showing that your pin is not connected together. So these two errors as showing that the pin is not connected together. So what I need to do, I connect these two together. So I'll close this, I'll go back, I'll connect these two together, and is now connected. I press save, I go to my ERC check again, I run it, and now you can see there is no error. So that is the function of ERC check all your connected together or not. So this, as I said, we can ignore for now. So that is our entire schematic. There is so we can just ignoring this one for now. So I'm just going to delete this marker. So that is a circuit which we have for this small demo. Now we need to do is we need to convert this circuit to a PCB board. So we're going to do that in a bit. But if you have any questions, you can ask now. So Shivam, can you check YouTube if there's any question?
Okay. Okay.
So any questions you have, please ask me now. So after this, we're going to design the PCB boards. Yep, Anul said that using flags help clean up the ERC. So power flags is there, which you can use. So if you want, I can show you how that works. So instead of doing that, is there any question? Shivam, are you seeing? Okay,
Yeah,
no questions for
there's
now.
no question.
Yeah, which is showing for the this one, which is showing for connected, it can remove using the global labels. So what it is like, it's you say that you place a label here which shows GND. Sorry, you show it's GND, and you connect it here. Okay, so it's still there. So I'm not really sure how to do that, but maybe Anul, you can show it afterwards. Okay, so for now, we're just gonna ignore this error because that is not a fatal error. So just gonna delete the markers and just gonna save. So I pressed the save for the schematic, put this into board design. So the next step which I showed in my presentation is now you need to associate all these components to something called footprints. So what is a footprint? So for example, LED can be a 5mm LED, it can be a 3mm LED, it can be a power LED. So you need to tell which components are connected to which. So for that, we need to associate the schematic to the components. But before that, we need to do one more step. It is a good practice to mark all the values of your components here. So how we now volt. So I'm planning to use a coin cell. I can say my battery is 3 volt. Now I'm gonna go on the my resistor is say 50 ohm. So I'll add 50R. So that is a good practice to do, so that I know that which is the value of my which component. Again, I'm just gonna press save, and now we move to the next step, that is associating this symbols to the footprints. How we can do that? So I remember when I was using Eagle, all the components have associated footprints. But as I mentioned in Kicad, you need to do that yourself. So it may sound one extra step that individually going and adding footprints for all the component, but it is also a beneficial step in a way that uh, you can associate any component with any footprint. For example, you can associate this LED to, let's say, a battery, which is not good, which you shouldn't do. But again, that is a flexibility which you can do. So if you are having 100 components, you do not need to have 100 footprints. You may have one component and 100 footprints for it. For example, you have one LED, same symbol, but that LED can have a footprint of 0805, 0603, or through hole 5 mm, or through hole 3 mm LED. So that is a really big flexibility provided by the Kicad. Now, how to do that is, the first step, you have to save the netlist. So netlist, again, as I mentioned, it has information of which pin is connected to which other pin. So if you go to this small icon over there, with .net, and now that information which pin is connected to which pin. Once we have the netlist, the next step is to generate. Next step is to associate the footprint. How you can do that is going to this small option called Run CVPC components, and as I said, Kicad is a collection of programs. CVPCB is one of them, which allows you to associate footprints to different component in the schematic. I'll run CVPCB, and you can ignore that. That's just for me. So in the CVPCB, you can see on the left-hand side, you have all the different libraries available. You have the current on your schematic. Do is find a footprint and associate with that. So let's say we have this option, filter footprint. I'll just this was the option. Okay, it's not showing the footprints on the right. I have not saved it, so need to save it to generate netlist. CVPCB. What's wrong?
Check for the filters at the top. If you have a filter enabled, it won't show.
There is no filter I see here. Is there any other thing? Okay, so I think there is some issue with this one right now.
You've tried all the filters?
Which one? I just see these two right here. I'm not sure what's wrong here.
That's odd. Check your library path for path, because I can see an error pop up when you try to do the.
This one?
Yeah.
This look good.
Yep. Okay. You're using version 4, is it?
Yeah, this is version 4, not upgraded
Okay.
yet. Not sure because this is working. This should work. Just see my installation once. Just give me a second, guys. Just debugging real time. So this should show all the components on the right side, but for some reason it's not. So just let's gonna see footprint libraries, and okay, libraries are there. I'm not really sure what's wrong. Okay, so I'm just gonna generate Netlist one more time. Does not exist. So what is saying? Okay, okay. I think I know what's wrong. So. Okay, let's hope this works. I think there's a path conflict for the libraries. By the time, if you have any question, you can ask. I think there is a path conflict and this should work. Hoping it does. So I'm copying all the libraries again to the path it's asking for, and let's hope this works. These are all the libraries. I'm just gonna give this path now. Document PCB slips. Okay, let's see. Okay, let's hope this works now. I think it should because it's taking some time to load. Yep, I think it works. Okay, perfect. So, can you see my screen?
Yes.
Yes, I am.
Okay. Okay, awesome. So yes, so the issue was, so my library was in some other path and Kicad was looking for some other part, but now that is solved. So this is the CVPCB tool inside Kicad. So this allows you to on the left, you can so Kicad allows you to have any component in your schematic to be mapped to any footprint inside your footprint libraries. That could be fatal sometimes. For example, you have a two pin LED and you are mapping it to 3-pin transistor. There is an audio problem. Okay, let's see if we can join from this one. Just okay, so I switched the audio device, and maybe someone tell me in the chat if audio is better now. Okay, yes, it's now better. Awesome. Okay, so we were in the CVPCB. So yeah, so in just 1 second. Okay, so in CVPCB, we can arrange any footprint to any component, as I mentioned. But again, it has drawbacks as well, because it allows you to associate any component to any footprint. But again, it is having a flexibility, which is, in my opinion, a better thing, but use it cautiously. So let's start with the battery one. So I need to have a small coin cell 3-volt battery. So what I can see is there are different libraries over here. So let's see something if we have something for batteries. So if you can see, I have battery holders over here, so I can use that. So there are a lot of components, footprints over here. But if you want to show only from this library, you can use this filter called L. Now it is only showing me what is available in my library on the right hand side. So I have 18 footprints of a battery holder, which is, if you can see, varies from cell holders, AA cell holders, to let's say a single coin cell holder. So on my PCB, I want a battery of single coin cell, which is a 3-volt battery, which I want. So I'm just gonna take this one. I'm just gonna take this one, because this is a component which I have and which I want to use in my PCB. So this is a CR2032 cell battery holder, which you can use. So, but now you need to associate your battery to this. So how you can do is by double clicking on that. So now you can see your battery one is 3-volt, but now it is also associated to battery underscore holder library. Inside you have Keystone 104 coin cell. So all these footprints are built into Kicad. But again, if there is any footprint which is not available on Kicad, you can make your own footprints. And how you can make your own footprints, that is a topic for some another day. But the basic idea is to have the data sheet of that footprint and see how distance apart are one pad from another pad. How one pad is a distance apart from another pad, and that is the basic idea behind having a footprint. Now we have two LEDs over here. So I'm just going to ditch the battery holder and I just go to the LED library, and you can see I have almost 98 kinds of LEDs over here, all from 0805 hand soldering. So this is a 0805 SMD LED. I have this over here. I also have some horizontal LEDs, as you can see, which are mounted horizontally on PCB. Let's use through-hole LED for this project, because these are easier to solder and not everyone is familiar with the SMD LED soldering. So I'm just gonna find a through-hole LED, and let's see if we have here. So I think, is there a through-hole LED? I don't think we have a through-hole LED, so let's go with the 0805 hand soldered. So if you see, so this is the footprint of 0805 hand soldered. So I'm double clicking.
You can look for a D5. It's a 5 mm diameter LED.
Yeah, it should be 5 mm. I think this one, right? Okay, this one. Yeah, okay, there we go. So we have this through-hole LED, and I'm not going to associate that with this one. So D5 for this and D5 for this. Now you can see I have through-hole LED associated to my LEDs. Now the last thing I need to do is have a resistor over here. So I'm gonna go to the resistors through-hole package, and there are a lot of resistors as you can see. So I'm just gonna pick through-hole 1.6, 0.6 mm. Yeah, there we go. So these are the resistors I'm gonna take. So now you can see my right hand side is populated, my left hand side is populated, and this means that all the components have been associated together. So now I'm just gonna press save footprints, and I'll exit the CVPCB. So I'm just gonna go back to my schematic, and I'm just gonna press once again to generate netlist. So as I mentioned, netlist has the details of which pin is connected to which pin, but it also has details of which footprint is associated to which component. So it is a good idea to have generate your netlist again. So I'll just save it. Now, if you go to any component and press E, that is to edit, you can see that it is also having a footprint associated with it, which is not available before. There's option for reference, value, footprint, and even datasheet you can add using a URL. So now we have all the footprints available. We have associated all the footprints. The next step, which I mentioned in my presentation, is to design a board. So now we have to do a designing a board, and on Kicad we have the tool called Pcbnew to design a board. And to go to the Pcbnew, you can either press on this icon which called run Pcbnew to layout printed circuit board, or either you can go from your project and on this icon Pcbnew. So you can go from either of this. Okay. So we have one question by Vishal Mishra. Is there any alternative of Kicad for Noobs? So I think Kicad is could be a bit intimidating for someone who's just starting with PCB designing, but it's not that hard if you invest some time, and there is a bit learning curve there definitely. But if you invest some time, you can definitely pick on it. But again, as Mason in the comment mentioned, there is a browser-based easy EDA tool which you can use. So I hope that answered the question. All right, so now we are in the Pcbnew, and there you can place all the components. Again, it looks similar to the canvas of eSchema, but it's a bit dark color, which you can of course change. Before bringing our components, I want to take a moment to show you what different things are here. So on the right hand side, you can see all the different layers available. So f.cu means our front copper layer, b.cu means back copper layer. Then the other layers which are of importance is f silk. As I mentioned, silk layer, you mentioned what you want to read on your PCB, like what is the value of a resistor, or what is the component number R1 or R2. Similarly, you can have that on back layer. F mask and B mask are your back and front solder mask layer, which I mentioned. Solder mask is to mask all the PCB tracks and only exposes the copper you want to put your components on. So the main layer which we're going to work today is front copper, back copper, front mask, back mask, front silk, back silk, and edge cut layer. Edge cut layer is basically the layer which defines your board boundary and your board shape. So this is the canvas, and the one tool that is going to be used is this one, which is add tracks and vias, which I'm going to talk about in a bit. But before that, let's bring all the components here. So how you can bring all the components here from here to this PCB. So I mentioned there is a thing called Netlist that has all this data. So we can import the Netlist by clicking on Read Netlist button on the top. Once you click that, you can have this option called Read Current Netlist. So if you are on the same project, it will read the current project netlist. But if you want to read from some other project, you can change the directory here and use that. So I'm going to just read the current netlist, and I'm going to click Exit. So as you can see, my components are right here now, but these all are very cluttered and not easy to see. So I need to disperse these components. So how you can do that is, so first you can go on this footprint mode, which allows you to move footprints. Then you do a right click. You go to global spread and place and spread out all footprints. And what it will do, it will spread out all the footprints for you. Now you can see we have a battery holder. We have a resistor, two LEDs and one resistor. Now we need to place all these components together. So
I'm guessing just let's for the fun this let's do one thing or maybe not, like we are good with the through hole components, right? So again, shortcuts. So I'm gonna use M to move my components around. I'm gonna use R to rotate my components. So same for Pcbnew and PCB schema. So this is your board, and this is how you can place it. So you can place it anywhere you want. So one thing I want is my battery holder to be on the one side of the board and my LEDs on the other side of the board. And how you can do that is on my battery holder, I press E. Over here, you can see that my board side is written front, but I want it to go on the back side. So I'll press back, and as soon as I click, you see there's a change in color, and it's now on the back layer of my board. So that is on my back layer. So now what I can do, I can place components on top of it because these are two different layers. So I'm going to place my LED like that, or let's just put it outside over here, like so we can put two LEDs like that. I'm just using my scroll wheel to change it, and I'm just gonna put my resistor here like that. Two LEDs resistor and a coin cell holder. So now I'm just gonna route that board, and you can see these are called rat nest, where you can see some flying wires going from one component to the another. One thing you need to keep in mind that your battery holder is now on the back side of this board, not the front side. So backside tracks cannot come to the front side tabs on their own. So something you need to use, it's called via. So what is a via? Via is something which connects one copper layer to another copper layer. So I'm showing you how you can create a via. So let's root these components, and on the right you can see add tracks and vias. There is an option for that. So I need to connect. So for better routing of this component, I just bring it here. Maybe that will make more sense over here. Yeah, that will make more sense. So I'm just gonna route this component. So I'll just pick one. So make sure which layer you are on. So my battery is on the back layer, but this arrow shows I'm on the front layer. So I'm just gonna click on this one. This will bring me to the back layer. One thing you can also see is on the back layer, the track are green in color. But if you are on the front layer, the track are of the red color. So make sure of that thing. One good thing about the through-hole components is that they have this a circular ring, which is also having a conductive material. So you can use any layer to route that. But again, for the sake of the demo, I'm just going to show you how you can come from back copper layer to front copper layer. So let's start from the back copper layer. So this is showing where I need to connect my component. This is, I want to connect it here. So how you can come from the back to the front is by pressing a V. So V is a shortcut for Kicad. So if you are pressing V, it will create a via. So now you can see after pressing V, I have created a via, and now from the back copper layer, I have come to the front copper layer. So that is how you can use a via. So now I'm just going to connect these components together. So double clicking on it completes the path. Now I am on the front copper layer, so just I need to complete all these different things. So I'm just going to rotate this LED for now. Let's place it here so you can all see it better. So now I need to connect these two wires together, but these two are on the front copper layer, so I can just connect it directly without having any vias. So just connecting it directly, and I need to connect this one, and I need to connect this one. So I'm just gonna do it again from a perspective of a via. So we're gonna go here, we're gonna place a via using V, and we're gonna connect it. So now you can see everything is connected, and one thing you can also use to see if everything is connected is you can see over here. So it says 0 unconnected. But if I remove any of this track, you can see 1 unconnected. So that's also one thing you can use to see. So now we have our board design ready, but we don't have a board outline. So let's have a board outline. So as I mentioned, the outline of the board, it's supposed to go on the edge cut layer. So first of all, I come to this edge cut layer. Now I can see everything I do is on the edge cut layer, which is my board outline. But I also need to take this let's say a graphic line, because I'm not going to use track for that. So how you can use a graphic line is you pick a starting point over here, you go to the other end, you click, bit ugly looking over there, but this does the job. Maybe not. Okay, there we go. So that's our edge cut layer. Now you can see we have a board outline. One thing we can do on the Kicad is we can have either the straight line or some curves line. So you can see we have some graphic polygons using this thing. But let's say for the sake of this demo, we want a circular PCB. So we can also have this circle over here. So what I can do is I can make a circular kind of PCB. So remaining on the edge cut layer, I press this circle and I make a circle in the shape of in the edge cut layer. But now I have a circular PCB. So that is one way of doing things. So but if you want a very complicated thing, you like a PCB batch, which I showed in my presentation, there are some tools which allows you to export Inkspace design to your Kicad, but that is a topic for some another day. So basically, your PCB is now ready for manufacturing. If you want, you can just quickly send the Gerber files by generating it. But there are a couple of things which we can do more. So let's see that. But first of all, I want to show you one of the very amazing tool in Kicad. It's called 3D Viewer, which allows you to see your PCB in 3D. So what you need to do is go to the View tab and click 3D Viewer. So you can see your PCB is available over here in 3D view, which is a really amazing thing. So I can change the preference here over here in realistic mode. I change the color of, let's say I want my Silkscreen to be white and I want my solder mask to be black color, because that's what we can do. And I click the realistic mode and you can see you can have a real good 3D view. So I have my battery connector on one side of the PCB and I have my 2 LEDs and 1 resistor on other side of the PCB. So if you want to have some other solder mask color, you can also change the color using solder mask color. And let's say we want to do an Oshpark design of purple color. So we can do like this. Okay, that's not really an Oshpark color, but you get the idea. So just gonna, let's say this maybe. Okay, but you get the idea. So this is how you can see your PCB in 3D viewer. This is when you install the Kicad, it has an option to install some 3D library which allows you to do that. So highly recommend you do that. So that is one thing which you can do. This is also a very important thing, very important feature to know if your components are not being in conflict. So sometimes it happens that you think that because these components are on different layer, they will not be having any conflict. But oftentimes, for example, I am having a through-hole resistor and a through-hole battery holder, and I'm putting them on top of one another. But I thought that they're on different layers, there won't be any issue. But on the 3D view, you can see that there would be issue when you are going to solder that. So again, you can use that from the 3D viewer thing. You can resolve that. I have a question from YouTube from where I can download some open source PCB projects and a dedicated link. So open source PCBs, there are different open source communities like Hackaday, Hackster, Instructables, where people like to put their project. If you really want to have a solid place where you can go and have some open source PCBs, you can go to open hardware. Open hardware website. There has a lot of there is a certification tab where people certified their hardware as open hardware, and you can use that thing to explore those open hardware project, and from there you'll get the link and everything you can download from those links. Question by Arshad. Hi, and is there any option to print the PCB here in India? I think PCB Alliance is a service in Bangalore which allows you to print PCBs. Also, there are a couple of services in Ahmedabad. I'm not really sure about the name, but again, if you can Google that, hopefully you'll find that. Okay, so there are a couple of more things I like to do on my PCB. I mentioned about the Silkscreen layer where you can put some data of what you want to see. So we can use that layer to put some screen. For example, I have the text here, and if I go to my front silk layer, that is f.silks, I can say that this is my LED 1. This is my LED 2. Yeah, I'll put your name as well. R1 is already there, and let's put a name over here. So we can say made for Shivam. So you can have your name printed over, let's say, over here. Okay, so you can also have some components. So for example, there is an inbuilt feature in Kicad called Bitmap-Component. It allows you to convert your bitmap images to something which you can place here. I'll give you one example. Oops, no, we don't want to close that. I'll give you one example. So if you go to this tab, it's called Add Footprint. And if I press over here, let's say, I'll say select by browser. So this is again opening something. So let's see, if I go to symbols, there are a lot of symbols over here. And let's say I want to put a Kicad logo over here. So I can do that as well. So let's use that. So Kicad logo, we can place on Silkscreen, and we can place another text. It's called hashtag made with Kicad. And this way I can place over here. So that is gonna print on your Silkscreen. You can again go to the 3D viewer and see that. So you have made with Kicad, and we have made for Shivam, and everything else is there. LED 1, LED 2 is there. I mentioned that LED 1 is, let's make it uppercase. Okay, one last thing I'm going to show you is how to add a ground plane. So PCB manufacturers, what they do is they have this reductive process of manufacturing. So there is an additive process where you add different layers to make something, and then there's a reductive process where you remove layer for something. A good example of additive process is the 3D printing, where you add layers one by one and you make something. A good example of reductive process is the laser cutter. You have wood and you remove the unwanted part and you get what you need. So PCB manufacturing is a reductive process. What I mean by that, your entire PCB layer has copper and you remove the unwanted copper from it. So if you are sending this board like as I am showing on the screen, a lot of copper will be removed because there is a lot of empty area. Also for some other reasons, like having good better electrical and heat characteristics, we can keep some of this copper, and that is something we call ground plane. So what I'm going to do is I'm going to add a ground plane on my bottom layer, and I'll show you how that looks. So there is a feature called add filled zone. I'm going to click that. I'm going to click on my front copper layer. I'm going to start from here. So I'm just going to click one. I'll select ground. I'm going to select ground. I'm going to start making from here a straight line. So you can see there is a zone forming there. I think I did less there, but that is okay. We are not. It's not fatal. I'm just going to double click and close this. So now this is enclosed in this sort of some square. So if I now press B, you will see that the entire area is covered with a ground plane except the path which are not ground. So that is a small thing which you can do. So if you see the PCB now in the 3D viewer, you can see that if it's in the realistic mode, maybe you would be able to see that it's more dense now. So it's having a lot more copper than before. In the similar way, you can add a pad on the a plane on the bottom layer. So if I go on the bottom layer, let's see, I'll do battery 1 this time because that's a positive pad. So I'm just gonna trace this one. So I'm just gonna close this over here. So if I press B, there is also a layer on top of on the bottom layer. So again, if you can see on the 3D viewer, you have a bottom pad, you have a front, and you have your Silkscreen written with made with Kicad and all kind of things. So that is a neat feature. Okay, so the second last step is to one more thing is you can hide all the layers and see how your PCB is looking. So these all are different layers. If you untick that, you would be able to see what are there on different layers. So all these layers are useful. One last thing, second last thing is to do a DRC or design rule check. So how a design rule check is works. So there is an option for design rules in Kicad. There you need to set your rules. So my rules are set like this, that I want a 0.2 clearance on everything, 0.25 clearance. That could be a mil or millimeter depending on your board house, and the size of a VI is 0.1 mil. So that is I have set myself, and you also need to set yourself. How you can set that is by checking from where you are going to manufacture. So I'll just show one site. So let's say I manufacture for JLC PCB. So that's one of the manufacturing board house where you can manufacture from. So on their website, there is an option called capabilities. So that there they have mentioned what are their capabilities. So they have shown that we can do 1 to 6 layer board. So you can see dimension tolerances plus minus 0.2 mm. Thickness is 0.4 to 2 mm. Minimum trace width is 3.5 millimeters. So all these rules are available on all the board houses site, and you need to set that in your DRC checker over here. So over here you can set everything. So that's what I've done. So now if I run this DRC check and I'll start the DRC, you see there is no error here. If there is any error or problem, it will be shown here. So that means my PCB is good to go, and it will be good manufacturable. So the last thing from this software which I need to do is I have a question: how to route PCB lines? What are the basic routing rules? For example, 90 degree should not be used. So a really good question. So I'm not an expert PCB router. So one thing is you can use a good automatic PCB routing software like push routing techniques. Also, there are some good documentation on Kicad and other forums which shows what are the good routing techniques, and you can read that and you can refer that. And I'd say that it's all about the experience. The more PCB boards you make, the better you get in routing your boards. Okay, so everything looks good. There is no error. The last thing is we need to do is generate Gerber file, because Gerber is something that the PCB manufacturers want. So to generate Gerber files, you need to go on this small icon. It's called plot. So if you select plot on the left hand side, you can see all the layers which you want to generate. So I want to generate my front silk, back silk, front copper, back copper. I also want to do solder mask layer, and I also want to do the edge cut layer. So these all layers are important to me. I'm gonna press plot, and it will save all the Gerber files in my current project directory. Also, I want to generate the drill file, because it is necessary for where you put the drill. So I'll generate the drill file there, and I'll say drill file. So one more thing is sometimes people like to put some kinds of mounting holes on your PCB. So how do it multi-stack type design? I'm not really sure how to answer that, but if you are saying that multi-stack PCB, so one thing is to do is have some mounting holes on two or four sides, and make that mounting holes conductive, and you use some brass standoffs to conduct signal or current from that. One way is to do that. Second way is for example, in Hacker Day, in Open Hardware Summit batch this year, I think Anul would be able to answer. They have 2-layer PCBs, and they're using some flexible kind of the connector for sending signals from one PCB to another. So there are a couple of things, a couple of ways which you can do multi-stack PCB designs. But I'm not the best guy to answer that. So talking about like if you want to put a drill hole on a PCB, for example, if you want to make it a keyring, so you can also do that. So if you go to the add component, you place the component, you say list all, and I'm looking for is called one pin. So it is already there in Kicad. Okay, so it's let's see, select by browser. Yeah, sure. Anul will answer your questions later. So looking for what's that called? It's called one pin, but it should be in mounting holes.
Either mounting holes or pin headers.
Yeah, pin headers. It's what we are looking for. So it's pin headers. We should have not this one. We need a one. Where is that one? The circular one. I forgot the location of that one.
Well, version 4, I stopped using it long back. So
Yeah, I think it's
the mounting hole library is probably in that.
Okay, so
Or it's in the devices library. Look in devices.
Devices. Where is devices?
It's either device or devices. Can't remember.
I think it should be in connector as well. Yeah, one pin. Okay, there we go. So that's the thing which we are looking for. So let's say if you want to make a keyring, so you can place one mounting hole over there, and again you need to read out the copper. So the shortcut to do that is press B. So once you press the B, it's get detached from the copper layer, and you can see in the 3D viewer you'll have this mounting hole which you can use to have your keyrings kinds of things, or you can have multiple mounting holes and you can use them with the 3D printing enclosure. So that's one way to do that. So again, we need to generate the Gerber files again. So I'll press save. I'll generate the Gerbers pressing plot. So plot, it generate all the Gerbers and generate drill files. I'll say drill file, it generate the drill file, and it generates everything in your current project. So that's the one. So every Gerber file is there. So I'll just do, what I like to do is I like to make a new folder called Gerbers. Oops. Yeah, so I like to make a new folder called Gerbers, and I'll put all the Gerber files in that folder. And also I need to put the drill file there. I hope there is no file remaining. Yes. So now I'm gonna zip this to .zip, and this is the file you need to send to your board house. So it's a good idea to also send some 3D view renders for your board with this file, so they can see and they can look how your board will gonna look. So they will come back with less questions. But for a board like that, it should be okay. So I'll show you how to order board as well. So let's say we want to order from Oshpak, which is one of the board manufacturing house in USA. You can go on the browse for files option there. You can upload the Gerber files here, the zip file, and you can also upload the entire project file. They allow nowadays, but it's easier to just upload the Gerber files if you are confident enough. Also, there is a built-in Gerber viewer for in your Kicad, which you can also use. But if you are uploading your files, that took long. That shouldn't take that long, but yeah, let's wait for that. Okay, there you go. So that you have uploaded, and now you can see your board ready for manufacturing. So this 2-layer board, so 3 boards will cost $47.70. But of course, I have made it big just to show everything, because there are very few components. You can make it small and you can reduce the cost. And also, if you're advanced user, you can do some kind of a panel and you can reduce the cost. So yep, pretty much that. So that was all for me in this Kicad workshop. And that's how you go from having a schematic to designing a board to finally ordering it. And once you get the board, you can solder it and make a good keychain out of it. So again, a heavily requested workshop at ILUG-D and HHC, and wasn't getting any time to do that, but now we had this online session. So yes, let's take some questions, and hope you learned something new, and hope you enjoyed. So yep. Yeah. Okay. So any questions on YouTube or? Hello. Yeah, thank you very much. Yeah, so Anul is here with us, and he is also streaming about Kicad on weekly basis. So follow him on Twitter. Anul, maybe you can drop your Twitter handle, and whenever you stream, if anyone is interested, they can join. And as I said, I'm not the expert, but definitely he is. So any questions you want for him, maybe you can ask now.
Ayan, Ashok here.
Shivam, is there any question on YouTube?
Nope. Enthusiast wants to speak. I guess he raised his hand.
Ayan, Ashok here. Can you hear me?
Oh, sorry, I switched off my speaker. So yeah, you were saying something?
Hello.
Yeah.
Yeah. Hi, this is Ashok. I just want to know. Okay, we did the PCB design part, and we have gone for this up to the ordering and all. There is some PCB designs which need like few kind of requirement like conformal coating and other kind of coating on that. So how can we get that on the PCB itself?
So as far as I am concerned, I have done some conformal coating, but that is after I have ordered PCB and soldered all my components. Then I put a silicon conformal coating, but I am not really sure if there is any feature of getting PCB conformal coated from board house. I'm not really sure. Anul, are you aware of any such service?
Not really. This is more of a post-production process. So you make a PCB, you assemble it with parts, you test it to make sure everything works, and then you do conformal coating, because conformal coating just about covers everything, including connectors or whatever. So it's something you do at the very end. Ideally, it's done on a large-scale production. So board houses or vendors who are subcontractors making volume PCBs, they are the ones who will be doing it. Essentially, it's some kind of a spray coating, which is silicon-based, so it covers everything and makes your board, let's say, humidity-proof. I wouldn't call it waterproof, but it protects against humidity and certain extreme conditions.
Yeah, right. So
You also have to start worrying about other stuff like thermal issues, because the conformal coating increases your thermal resistance. So there are a lot of thought needs to be going into that, and ideally you would be doing it only if you want to do really large volume productions. For a few hobby projects, you can just buy a CRC conformal coating spray cans from Amazon and do it yourself, like Ayan has done. It's pretty easy.
Right.
Like spray painting, you just take a PCB and coat it all over with it.
Yeah. Okay. Yeah. Though it's a nice session. Thank you very much.
Even it was like if you do conformal coating without having component being soldered on, there's a high chances that you won't be able to solder it because the silicon takes over the board and it there will be no exposed pad. That's what my experience is, because I've did conformal coating on one of my drone to make it a bit waterproof, if you say. But yeah, I have some issues with that. So I hope that answers your question.
Yeah, got it. Yeah, thank you.
Awesome. So do we have any more questions? Mason would like to speak. Yeah, sure.
Hey, can you listen to me? Am I audible?
Yeah, you are audible.
First of all, it was a really great session. I really learned a lot, but I missed a really small part when you were making those PCB tracks in Kicad. So I want to ask this: is why not, users, if anyone is anyone is making those PCB tracks, whenever there is a turn, they turn it at an angle like 60 degrees or 45 degrees or something. Why not 90 degrees?
Yeah.
I mean, save some space.
Yeah, it does, and it actually is one of the questions that has come a lot of times in all the PCBs forums, and whenever we talk about the PCB design. So, what I have read about it is there is not one single explanation about it. So some folks like to say that because at 90-degree the current either leads if it's a conductive circuit, or it lacks if it's an inductive circuit. So it messes up the power factor. So that is one of the reasons which you shouldn't do. Some folks like to say that at 90-degree there is a chances of connection breakage, and it makes your tracks a little bit fragile. So I'm not really sure what is the exact reason, but it's not considered as a good practice. So Anil, what do you think?
Wait a minute. Sorry, I was distracted. I had a phone coming in. But yeah, this is about right angle tracks. There is no real rule for it. It's more of an aesthetic reason. It's also something that has come to us from the days before computers, or rather before the more modern manufacturing process for PCBs. What you want to avoid is what is known as acid traps in your layout. Acid traps are formed, basically you get your PCB made by etching copper away using acid. So that's how the process works. You take a piece, FRP piece that's coated with copper, and then you remove the parts that you don't need using acid, ferric chloride, or whatever else you use. Now, if your tracks are at an angle that are not that are at a shallow angle, let's say 30 degrees or 60 degrees, that causes the acid traps, which means basically acid accumulates in those sharp corners and then eats away the corner of the track, leading to more lesser yield when you make volume production. So one is you never connect two tracks to each other at angles shallower than 45 degrees. So you can't have 30 degrees or 60 degrees angles, because those creates the acid traps. The reason for 45-degree turns is, I would say, purely aesthetic. It looks good essentially, and making track layouts. I mean, drawing schematics is easy, but track layouts is half science and half art, as I mentioned in my comments. So there's a lot of like each part you put on the PCB, there are at least 8 different ways of mounting it, depending on the top or bottom surface, and facing north, west, east, south, or if you take 45-degree angles, you have even more options. So each connector, each LED, each IC has so many different options in terms of mounting and installation. So that makes a little of thinking out of the box in terms of visualization. You have to think ahead of how a part needs to be mounted to make things easier. After you've done routing, let's say 200 tracks, you don't want to change a part layout after you've done 90% of your board, because you'll have to break everything apart. So you have to think less as an engineer and more as an artist when doing certain parts of the PCB. And at other times, you have to think more as an engineer and less as an artist when you're doing the technical parts, like laying out an antenna, for example, and so on. But again, to summarize, 45-degree angles is more for aesthetic reasons. There is no real science in the 90-degree bend causing anything to do with current or emission or any of that. at least until you get into the megahertz or gigahertz ranges. So for DC, it makes no difference whatsoever whether your tracks are at 90 degrees or 30 degrees or whatever angle you choose. Up to a couple of megahertz, again, nothing. You should really worry about it for those reasons at least.
Awesome. Hope that answers your question. Listen.
Yeah.
Yeah. So, any more questions before we wrap up? Any feedbacks? Any questions? Anything? I'm just gonna paste one link which enthusiast has asked for. So this is like one of a document for best practice about designing PCB. So which I have read. So okay, my phone is acting really weird today.
While Ayan is doing that, for those who want to follow through everything that he has done, of course, it's all there on YouTube. But if you want to follow this at a slower pace, then you can check out Chris Gamel's series on Kicad. It's a very good starting point. It's called Getting to Blinky. You can just look for it on Google and you should get it. Contextual Electronics, Getting to Blinky is a nice series of tutorials. Each video is about some 15-20 minutes and goes from schematic layout all the way to Gerber's. So check that out.
Yep, there you go. Yeah, so Getting to Blinky is by Contextual Electronics, Chris. So
yeah, I can drop a link here.
yeah, you have for version 4 and version 5. I recommend starting with version 5 directly if you have not used Kicad before. But if you're already using 4 and you want to make a transition, then you can also use that. Question from Telegram. Thank you for the awesome talk. During footprint association part, how do we know the right footprint to use? That's a really good question. So the PCB design is not a top to down or bottom to top approach. So it's like coming back and forth over that. So for example, you need to plan beforehand what components you are planning to use, and even if those components are in production or you can find them easily. So for example, if you want to design this LED board and you want to add on-off button. So on-off button comes with in a lot of sizes, in a lot of shapes, and a lot of manufacturers make it. So for example, on the net, you have seen a circuit where someone is using SMD on-off button, but that button is not available in your area, or it's very expensive, and you want to use some cheap one. So you can go to distributors like Element 14 and DigiKey, and you can search for, let's say, SPDT or DPST kind of switches, and from there you can decide that this is the component I'm going to use. So you can, if that component footprint is already available in Kicad, you can associate it. You can associate it with that. Otherwise, you need to go to its data sheet and you need to make your own footprint. So that is how the things work. So you need to have this clarity that which component you want to use. One more example I can give. Suppose you want to make an Arduino board. So for example, you want to make an Arduino with Atmega 32.8 PU, because that most of the people can relate to, right? So if you are good at soldering, you may want to go for an SMD version, which is like TQFP or a QFN package. But if you are not good with soldering, you might consider going with the through-hole version or DIP dual Enlight package. So that you need to think. Both circuits are correct, but footprints are different. Microcontroller is same, footprint is different. So depending on availability, depending on cost, which components you want to use, that's how you associate the footprint. Hope that answers your question. Do you have any other session following to this? So not on Kicad, but as I mentioned, Anul is doing almost weekly streaming, so you can follow him on Twitter, and you can join his streams on Kicad specifically. But at ILUG-D and Hardware Hackers Club, we are having different sessions coming up, and the plan is available on Twitter. So next one is on Saturday. I think it's on Emacs. Emacs is a text editor. So setting up Emacs is there, and then there is some on Apache Kafka, I believe. So yes, you can follow on Twitter for that.
Yeah. So thank you, Ayan, for joining. And thank you.
Yep.
I think she's not audible.
Yeah, I think your voice is breaking.
Okay, so can you hear me now?
Yeah, we can hear you now. Awesome.
Okay. So next one that we have in series is on 10th, and which is actually a quiz and with a community meetup for ILUG-D and HHC combined. So make sure to join us and follow our virtual calendar for this series of virtual meetups. So thank you, and I think we'll wind up for today now. Okay, bye.
Yeah, sure. Okay. So thanks a lot for joining, and I'll see you around. Bye-bye. Good night.
Good night, man. Good night, everyone.
Awesome, great meetup. Thank you.
Thank you, Anul, for joining.
Thank
See you around.
you.
See ya.
Awesome talk, Ayan.
Thank you.